Today, let's talk about game management for a private game. When a player is hosting a private game, you may want the private game owner to have some privileges. In this example project, we will allow the private game owner to invite friend, kick player, manage team, and terminate the game session if he leaves. And we will disable friend invitation for the other players. And the player who created the private game is the owner. So, we need to verify the owner on the server to allow them the privilege of using these operations. As we saw in the previous video, we used the access token to get the user info when creating a private game and stored it in the game properties. This means we can now use those properties to identify the game's owner. To get the game properties on the server side, we can use the start game session event from the process parameters. This event includes all the properties that were passed in when the private game was created. If a player wants to join the game, they need to supply the player session ID that they got from the private game's GraphQL web API. If they don't, their request will be rejected. Once the player session ID is provided, the game mode uses it to create the corresponding player character in the game. When the player characters begin play runs, it accepts the player session ID and uses it to fetch the data stored in the player session. This includes the user's identity info. Once verified, if the user is identified as the owner of the private game, they'll be granted the privileges to carry out certain actions. Since all actions go through the client, we'll need to tell the client to open up the control panel so the owner can access these operations. However, we need to be careful here because this code is executed in the begin play function on the server side. The enable game management function is a replicated function, and it will be triggered immediately after the replicated creation of the player controller and player character. At this point, the begin play functions on the client side for the player controller and player character may not have been executed yet. Therefore, we need to use a delay of 0 seconds node to wait for one frame to ensure that begin play has already been executed on the client side. To ensure that only the private game owner can invite friends while preventing other players from doing so, we simply return the game session ID in the GraphQL web API's create private game response, but omit it in the join private game response. This way, only the owner has access to the game session ID needed to send invitations. Since kicking a player requires access to lower level server logic, it can't be done purely with blueprints. The example project includes all the code needed for this functionality. We've built a UI to help manage teams, but here's something to watch out for. Unreal Engine's replicated functions don't support sending arrays or maps. So to upload team info to the server, we convert the data into a JSON string first. Additionally, when the owner of a private game leaves, the game should be closed. This can be done by executing the following piece of code on the server side.
In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show you both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash dot slash initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms Linux ARM64, pick development and the server and package the project, and that's it. After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file. And then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project.
We can set a position update interval here to convert a WebSocket MMO system to the real time. You can change other parameter based on your use cases. After the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result.
We have registered 3 players off screen: test user 1, test user 2, and test user 3. Test user 1 and test user 2 have both added test user 3 as friend in friend system. If you are interested in a friend system, please refer to the friend system video tutorial. Let's create a private game in test user 1's client. We have changed the WebSocket MMO player character color to transparent, so you can see test user 2's transparent MMO player character here. Please refer the WebSocket MMO video tutorial if you are interested with this MMO system. Test user 2 has joined the private game. We can see only test user 1 has the game management panel option because he is the owner of the private game. We can see only test user 1's friend panel has the invite button. Let's try to kick test user 2, and we can see test user 2's client is kicked. Let's try to join back to the private game on test user 2's client. We can manage players in each team by drag and drop. Once the team assignment is sent to the server, the player's character will change color based on their assigned team. We can see test user 1's player character is blue and test user 2's player character is red in both clients. Let's try to exit on private game owner, test user 1's client. We can see that test user 2 got kicked as well.
That's all.